fourth graders. So we're almost done with our week. This is Thursday's lesson, 12.12-6, and it's titled Improper Fractions and Mixed Numbers. And I really wanted to define both of those terms for you. As it is, I mentioned in my notes, it's a hard lesson and concept to kind of get into your head, and it just requires practice. This is something you really need to know when you get into upper math, especially when you're dealing with decimal systems or the decimal placement system and sort of how to convert. It's really important. So let's go ahead and define these two terms. The first one you're going to come up to is a mixed number. Really focus on the word mixed. Mixed means it's going to be combined, something different. Like when you mix the batter of a cake, you're combining different elements to make that cake. Well, a mixed number is going to have different elements to make a mixed number. So it's a number that has a whole number, so imagine something whole, and it has a fraction piece with it. So it's mixed between a whole and a fractional piece. The next word you're going to hear would be improper fraction. And my favorite way to remember this is something that doesn't look right. And I always used to say, it's a little girl wearing a dress, standing on her head, doing cartwheels. And my mom would say, that's not proper, young lady. Of course, nowadays you have shorts underneath your dresses, right? So an improper fraction is a fraction in which the numerator, so that's the top number, is greater than the denominator, or it could be equal to the denominator. And I'll show you a couple of examples of what that looks like. And we'll go into the actual concrete numbers so you can see that too. And I want to show you physically what we're going to do here. So we're going to have a little cooking lesson in my kitchen. I'll set that to the side. So we were on a walk last night and we got some oranges. So I have 2 oranges. So what I'm going to do with these 2 oranges is I'm going to divide them in half. So now, oh, those are good looking oranges. Look at that. Those are really nice.
Tasty.
Looking. Yeah. So 2 oranges. Now we have 4 halves at this point. So I want to show you what a mixed number looks like. So we have exactly 4 halves. I'm going to put this one back together again. So we are talking about 1 whole orange. And I'm going to take one of the halves from my second orange and bring it over here. This is called a mixed number. We have 1 whole and a half. Now how it becomes improper is kind of confusing. So I'm actually going to go to my board and draw this for you. So you're saying we have 3 halves. Keep that in mind, 3 halves. We can push 2 together to create a whole, but then we still have a half remaining. Okay, so I'm going to show you what that looks like mathematically. Okay, a little orange juice here. Hold on. Let's just do a quick wipe. Okay. So using our orange as a demo, I'm going to draw some pictures. I chose an orange because they're super easy to draw. It's a circle, right? So we have, going back to our visual, we have 2 oranges, and what I did was I cut them in half. Okay, so then now I have technically 4 of these halves. They look like little eyeballs, sleepy ones. So we have 4 halves. Okay. So when I brought them back together, I had 1 and a half oranges. I don't know why I didn't draw just half. Okay, so I have 1 and a half. What does this look like if we're talking about improper fractions or mixed numbers? Well, this is going to be what it looks like as a mixed number. I'm going to use a pound sign, shorten it up. It's going to be 1 and a half. So we have 1 whole and 1 half. Now, what does this look like when it's translated to an improper fraction? Kind of tricky here. This is where it gets a little tricky. So I erased my visuals, probably shouldn't have done that. So I still have my 1 and a half oranges. I have 3 half oranges. It's going to be represented 3 over 2. And then you're going to have to break this down. So really what this is a division problem. So we have 3 halves. I know you can't see how that means 3 halves, but it's represented over 2. And truly, if you can remember, this is 1 half. So now we have 3 of those halves that looks just like this. We have a half, and a half. So I should have my dotted line so I can see his cut. So the 3 halves over 2 over 1 1/2. So this is a division problem, and it looks like this. It's 3 divided by 2. And this is why they teach the division chapter first. So we know that 2 will go into 3 one time with 1 remaining. So all these parts, your quotient, your remainder, and your divisor, all have very important parts to what a mixed number looks like. And this is the crazy translation of it. We have 1 whole. That's what the quotient represents. So we have 1 whole. We have 1 remaining. That's your numerator. And then finally we have 2, which is going to be what you divided it by in the first place, your divisor. So it's 1 1/2, and that's really what a mixed number is. And our whole lesson today is actually taking mixed numbers and moving them to fractions and so forth. So I'm just going to jump right into the algorithm of it. Let me grab my notes so that I can make sure that you get to see again. They first introduced this one. They say, okay, what is this? So you can see 5 wholes and a quarter. So this is a what? Mixed number or improper fraction? That's right. It's a mixed number. It's mixed with a whole and a fractional part. You might be provided something like this. Let me see. Give me one. I'll go like this. 10/3. Is this a mixed number or an improper fraction? You're right. It's improper. You have a heavy numerator and a small denominator. This is a division problem. That's really what that means. So if we went back, I'm going to take you back to our original that I just showed you, 5 1/4. So if you wanted to think about it, well, it's 5. If I had 5 oranges, I'd have 5 oranges. And if we took an orange, we would divide it into quarters. And I would take out, this piece right here. And technically, that's 5 oranges and a quarter. That's what it looks like. They want you to take these numbers now and put them into mixed, or they want you to translate them into an improper fraction. So it's really translating mixed numbers into improper fractions and improper fractions into mixed numbers. So I'm going to show you an algorithm that's actually a really sweet way to remember this. Okay? I use this circle motion like this. I draw these arrows. Okay. And really what it means, this is a multiplication problem right here. And this is an addition problem up here. So it is 4 times 5. So really what's happening in this algorithm, 4 times 5, 20. That's right, 20. Now we have to add the 1. That's what that means. We're going to add the 1. So you get 21/4. So that is taking a mixed number and moving it into an improper fraction. You can take it apart again. So let's just say we were given 21/4. I'll put that over here because it's easier to work from left to right. 21/4, and they say, okay, what is this as a mixed number? So it's a division problem. And there's our special little way we do it here. So go 4 on the outside, divided by 21. And we've talked a lot about compatible numbers. We know that 21 is not compatible with 4, but we do know something that is close. And we can think of the multiplication factor of 5 times 4, which is 20, and we're left with 1. So we have these 3 really important parts that we talk about again. Okay, I forgot to bring my remainder up there. So we are saying that this number 4 can go into 21 5 times. Our quotient becomes our whole number. Then we're going to look at our remainder and look at our divisor. We're saying that it's going to go in 5 times with 1 of the quarters remaining. And that's really what it means. So again, quotient, remainder, divisor. Yeah, all those crazy parts go together to equal a mixed number. So again, today's lesson is about translating both of those. I'm going to give you a couple of examples and then we'll move on. It's going to give you some nice visuals, which I include. So our GP today, okay, GP says, write a mixed number as an improper fraction, Write each improper fraction as a mixed number and a whole number. Use models to help you. So the models are going to provide for you, and this is where the models get super confusing. They always give you this whole bar. So they give you 1, so you can have comparative pieces. This 1 is not part of the problem, and that becomes confusing in the books of visuals. So they're going to give you 1 and 3/8. And they're going to show you a picture of it. So 8 is our denominator. Again, super, super important. So you're going to see this again divided into 8. Let's see if I can do this really quickly. All right, did we get 8 pieces? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So each one of these pieces represents 1/8. And to save time, I'm just going to show you just a small one. They're going to give you another part. They're going to give you another group. So if I took time and I labeled each and every one of these, oh boy, and it's a lot. I said I wasn't going to, but I think it might be better if I do. This is what 1 whole and 3/8 looks like. Now remember, this 1 is not part of the problem, but they give it to you so you can see that this is a measurement of 1 whole. So to keep it from getting too confusing, I'm just going to erase this. The book, you can just cover it up if it bothers you. So this is what it looks like on a model. We have 1 whole, all broken up into 8. Remember, the denominator indicates what sort of fraction strip you're going to use. And then we have 3/8 remaining, so 1 and 3/8. So this is going to tell you to put it back into an improper fraction. So if you need the model, use it. Count up these pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So really, in essence, you're dealing with 11/8. That's how you would convert a mixed number into an improper fraction. You could know the algorithm of it. And the algorithm is really, really easy. I'll show you here again. Algorithm is just, it takes less time. You're going to multiply these two numbers. 8 times 1 is 8. Then you're going to add 3. So this part is the add 3. So that's 8 plus 3, which equals 11. So 11/8. That's the quick algorithm to it. The visual models are there in the book to help you for this first round. Guided practice number 2 has another model. They give you, again, the whole bar. Remember, that's not part of the problem. They just show you that you're measuring it against something that's whole. They give, this one is a little bit nicer to draw. It's thirds. So in my third, ooh, that middle one really got ripped off. I'll try to do my better self here. This is good. So they have a picture that looks like this. Okay. So again, remember, 1 doesn't count. So if we're looking at this 1 whole and 1/3, okay, they give you, and I kind of cheated on that, they give you 4/3. And again, if you get an improper fraction, that 2 is kind of fixed. If you get an improper fraction, they want you to turn it into a mixed number. So in this case, how many thirds do you see? Well, there's 4 1/3. It's already shown to us. But if you were to translate that into a mixed or whole number, or mixed number, it would look like this. It would look like 1 whole, 1 whole and 1/3. Without the models, here's the algorithm. It is 4 divided by 3. Goes 1 time with 1 remaining. So again, these are the 3 important parts. So there's our whole, there's our quotient, here's our remainder, and there's our divisor. Okay? Try it. This is a tough lesson. It's going to take practice, so I want you to go ahead and practice. If you have questions, ask. Khan Academy is also a great place to assist. And guess what? Tim and Moby Brain Pop, they have a nice little lesson on this too, if you're still confused. All right. Thanks, 4th graders. Now, should we eat some oranges?
Of course. Tasty.